Thanks a lot, Dr. Patsy Moran, for joining us. Today, everyone, we have Dr. Patsy Moran. She's an environmental geochemist, and she's also Proud Minds alumni. And she's an entrepreneur who runs a whole business called Practical Geochemistry LLC based in Nevada. She focuses on geochemical characterization, geochemical modeling, and a lot of other things. She has led hydrogeochemistry-based studies in North America, South America, Australia, you name it. She travels a lot. Every time I talk to her, she's in a different location, and she has a wide range of experience about different other things, not just geochemistry. I leave the floor to you. Thanks for joining us today, Dr. Moran. Thank you.
Okay, excellent. Well, just appreciate that introduction and being invited to provide this talk about Mount Todd, titled "The Path to Restart of the Mount Todd Gold Mine," but it's really about treating and dewatering the Batman Pit, which is a primary component to actually restarting this mine. And so a really brief overview of the talk, which is, and let me know if you can't see these slides or if there's any issues, but I think we'll kind of hold the questions until the end of the talk, unless something comes up that really needs to be discussed. Then I think you're going to put that in the chat and then punt it to me if necessary.
Yeah.
Okay, yeah. Perfect.
We'll take out the Q&A.
Try to pay attention to the chat if I can. Actually, I'll move something here so it doesn't get in the way. Okay, so brief overview, which is I'll talk about project history, which is of course the mine project history, but also my history on the project. Then go into the Batman Pit water treatment, and that includes bench testing, selection of the remedies, looking at pilot testing, full-scale treatment, and then talk about the dewatering of the pit. So as already was mentioned, I am a master's and Ph.D. from Colorado School of Mines. Spent most of my time in Kubal Hall, so I didn't really see much of the campus. Applied chemistry is my degree. I went to Tetra Tech in 2008 and was basically taken under the wings of John Roselle. He was at Tetra Tech at the time, and then later went to Vista Gold and is still at Vista Gold. Basically, Tetra Tech was working on the 43101 documents, basically for the financial compliant documents that are put together for most mines. And if the people on this phone call don't know what a 43101 document is, probably should know if you work on any mining projects, because that's where a lot of our information is that we can get is contained. But while working at Tetra Tech, I helped out on the 43101 for Mount Todd, worked on some of the geochemistry, and Tetra Tech is still actively working on the project. So if you were to see the latest update on the 43101, it would be authored by Tetra Tech. They also are doing some hydrogeology, closure planning, and I was lucky enough to be able to do a little bit more work on the project when I moved over to Arcadis. I'll talk a little bit about that involvement, but it was basically looking at to look at one of the alternatives for full-scale treatment, which was not selected. And then a little bit of water treatment support. And then I decided to go out on my own in 2018. My husband was getting ready to retire, and it was a good opportunity for me. And I've been really successful, really fortunate to be able to be an independent consultant working in Nevada on some interesting projects and still be able to work on Mount Todd, mostly on geochemistry related support for the last few years. It's also worth mentioning the other people that were involved, more than I was involved on actually the pit water treatment and the dewatering, which is Micronized Mineral Solutions or Micronized Minerals Australia. Leon Torrent and his family basically designed the system and really worked closely with Vista Gold to implement this treatment, and a really methodical and kind of hats off to them for the approach that they developed with Vista Gold. And then Jill Woodworth, she was formerly with Ph.D., now with SLR. She's an ecotoxicologist. Ecotoxicology is her specialty, and really the work that she's done over the years to demonstrate that this water is not toxic to the receiving waters is, high quality and just an excellent person to have on the team. So shout out to those folks as well. Okay, moving on to the actual project. So let me get my laser pointer out here. So what we have is, let's try this again. Here's Australia. The map area up here is the Northern Territory. Then you go down from Darwin on the coast. You travel about 300 kilometers to the Mount Todd Gold Project, which is accessed from the Stewart Highway, and about 56 kilometers to the north of Catherine. So really good infrastructure in the area. It is a brownfield site. That's something that's really important. Obviously, we're talking about dewatering a pit, but so I'll just show you some of the facilities that remain. So this is Batman Pit right here. The facilities, your process plant, etc., used to be in this area. There's low-grade ore stockpiles. The heap leach pad is here. Then you have the tailing storage facility, some small mineralized pits that are actually not going to be the topic of this conversation, but worth mentioning. Gulf talus pits, raw water pond, the waste rock dump, retention pond, and then I'll talk about this quite a bit, the Edith River to the south. Edith River and its tributaries are designated as protected beneficial use for aquatic ecosystem. And that's really important as far as how Vista was able to negotiate to have this pit dewatered. I was thinking about Allison's talk last week. I don't know how many people were able to attend, but I really found it to be a great talk on social environmental governance. And she asked us kind of what were those words when we think about social environmental governance and what's the most important thing. A lot of us said trust and respect. And I think that's what Vista Gold has been very successful at, which is that they've developed a really solid relationship with the traditional landowners, the Jawoyn Aboriginal Association Corporation, or the Jawoyn people. I'm just showing you here their traditional land, which is about 50,000 kilometers. And if you can see right here is where Catherine is. So it's kind of on that southwestern edge. Anyhow, Vista Gold does regard their relationship with the Jawoyn people to be one of the most important ones, and they've managed to continue to keep that relationship healthy. I think probably maybe a week ago, they announced a new update to the agreement with the Jawoyn Association. Basically, there were already these gross proceeds royalties, but looking more at protecting the historic, cultural, sacred sites, developing cross-cultural training, developing employment strategies, business opportunities. So as the site moves closer to actual operations, they've solidified those relationships. And my understanding is that it's a very healthy relationship. So moving on to the actual history of the mine. So historic mining has been conducted at the Mount Todd mine for 130 plus years for gold and tin. And so to keep that in mind, but the actual discovery of the Batman deposit was in 1988. Batman deposit is within the Proterozoic age Pine Creek geosyncline. And this is PCG is the host to 250 identified gold deposits. Something like 2 million ounces of gold have been mined from the PCG, and it's 5 plus 1 million ounce deposits that have been identified. So it's a big player here in the Northern Territory. The Batman deposit is hosted in the Burl Creek Formation, and it's a sequence of hornfelds, interbedded greywackies, and shales. And if for those of you who heard us chatting a bit about the rock, it is very hard rock, some of the hardest rock in the world, and that, as Eric mentioned, Tetra Tech and Vista Gold helped to address that concern that really were problematic for the previous owners of the property or the owner operators. So in 1993, Pegasus Gold became the owner operator of the site, and that was when commercial heap leaching began. They had a 400 million ton per year operation, 4 million ton per year operation initially, expanded it to 6 million tons, and then ultimately in late 1996 commissioned a flotation and carbon and leach plant to improve recovery. They were already having some issues there, and that was an 8 million ton per year flotation and carbon and leach plant. pretty quickly after that, they shut down the flotation circuit and actually put the entire project into care and maintenance. They cited low gold prices, which were only about $300 per ounce at that time, US dollars, low plant throughput, high reagent consumption, and poor gold recovery. But as I mentioned, that's been addressed. So when people talk about Mount Todd, they tend to talk about the issues with the crushing and the grinding, and it's probably the first thing that Vista Gold has to say. We've got that taken care of. So in 1999, for about 15 months, a joint venture between Multiplex and General Gold operated the site. And it didn't last very long, and most of the equipment was sold soon after. So when you go to the actual Mount Todd site, if you have that opportunity, there are no facilities there. There's no crushing, grinding, no process plant. Those are all gone, but there's still obviously facilities like what I showed you with the TSF and the waste rock dump and low-grade ore stockpiles. But in 2000 to 2006, the Northern Territory government took over operations of the site. And I think they were challenged by the fact that there is a net positive water balance here. And so there's a huge amount of water in this area. The wet season is from October through March, and that's where most of the rainfall occurs. And annual average precipitation in the area is 1.5 meters per year. So relatively small retention ponds for the different facilities. And with the desire to prevent any kind of issues with the tailing storage facility having too much water in it, or, you know, frequent uncontrolled discharges, which were occurring at the time from the waste rock dump, for example, they chose to put most of the water into Batman Pit. So I think that's a really important component here, is that the water in Batman Pit is a lot of it is from other facilities. And so in 2006, Vista Gold acquired Mount Todd and assumed care and maintenance of the property. This photo here is actually not completely filled pit lake, but Batman Pit. It's, I think, 6.6 meters of water had been removed by this time, but you'll see another picture here. It's just a great one as far as showing the actual Batman Pit. So speaking of Batman Pit, so this is circa 2006, and what you can see is this is about as full as it got, to 11 gigaliters of acid rock drainage from across the mine site. The depth of the pit is 120 meters, close to 400 feet. Storage capacity, as I mentioned already, 12.2 gigaliters, or at least I think I did. So basically they had one more gigaliter of storage before it would overtop. Then it would end up in the waste rock dump retention pond, then end up in the Edith River. So it was advantageous to come up with a solution to dewater Batman Pit as soon as possible because of that positive water balance. Surface area of about 32 hectares or 79 acres. So keep in mind that this seems like a big pit for some people, but maybe you mine engineers, it's not really that big of a pit, but it is a cone, you know, so most of the water is stored up here and much less water with depth. So that will come in handy when you look at some other pictures in a few slides. Water quality, not extremely acidic from an environmental geochemistry perspective, but still 3.2 standard units. Electrical conductivity of about 2,800 microsiemens per centimeter. So a lot of that, you'll see in some slides later, is due to sulfate. But, you know, at this time when it's acidic, the metal load here, I'm just showing aluminum, copper, and zinc were, you know, 112 milligrams per liter just associated with those three constituents. And you can imagine all the others that would be associated with the water at this low pH. So in order to discharge this water, they had a 5,000-fold dilution requirement to be met on the Edith River downstream of Batman Pit, because they were meeting, not just because it's acidic, high metal load, but also they were required to meet a 95th percentile species protection because there wasn't that many studies done yet at the time. And so that 5,000-fold dilution, they were able to actually dewater to some extent, but just not enough to rapidly dewater and move towards restart. So I think Vista Gold made the decision to do in situ treatment pretty soon after they took on care and maintenance. That's my mom. They do have a water treatment plant on site, but it's just a small line treatment plant. And it's worth noting that part of their closure plan is water treatment. An ex situ water treatment plant, I think, is part of their closure plan. So they're obviously thinking beyond just dewatering this pit and properly closing this mine site. But back to the alternatives that they considered, I was actively involved in this evaluation, and it was at that proof of concept stage where you're just dealing with like small scale bench testing, basically. So limestone, micronized limestone, I'll get into that quite a bit. Quicklime. Another one was hydrocalcite formation. This is an interesting technology developed by Grant Douglas and his peers at CSIRO in Australia. And basically it's the formation of precipitate that involves co-precipitation and pulling some of these other metals into the precipitate, and then it settles through the water column, picks up more load as it settles. And it's a very interesting technology. They did excellent benchtop test work, and it just was not the right solution for this project. I think mostly the reagent costs were a little high because the chemistry wasn't perfect as far as, just being able to create these very easily without a lot of additional reagent addition. But nonetheless, something that has worked elsewhere and should be considered when folks are thinking about in situ technologies. Boxall, you might be familiar with bauxite mining, and the tails from Boxall are red mud, and so, bauxite mining. And you basically add caustic to it, and it creates this material that not only has an alkaline component to it, but also co-precipitation absorption as well. And the test work that was done was interesting. It just is a very proprietary technology. I'm not even sure if it's still around. They may be, but some of that proprietary work caused us issues as far as making decisions about advancing it. We just couldn't get comfortable with the information they were giving us at that time. And then bioreduction by sulfate reducing bacteria. It stayed on the list through the initial stages, and I was able to do some test work with our partners, Arcadis's partners in Australia, and look at sulfate reducing bacteria, which were very successful. I mean, I think something like 99% removal of key constituents, some removal of the sulfate as well, but you do create this low DO environment that, there would have been some issues that were too high risk for Vista to comfortably take on as far as trying to discharge that low DO water. Not to say that it can't be done, it's just in this kind of environment, it just had a little bit too much risk compared to the technology that they chose, which was to use both limestone and quicklime, as I'll talk about. A very cost-effective and low-risk approach. I already mentioned micronized minerals, but they were the ones that did the original bench work. They did larger scale bench testing. They then did this pilot test I'm about to talk about in the decant pond on site, and then helped Vista with the full scale implementation as well. So stage one of the test work was to use micronized limestone, finely ground to 150 micrometers. And this is really important because I think the technology, everybody's used it. This is nothing new. It's just that a lot of us have used it where the particle size was too big. Some of the ARD metal load caused scaling of the limestone. It never was fully accessible, sank to the bottom of whatever water column. And so it just kind of was not as successful as I think that you'll see through this test work here. And I am a big fan of implementing this technology using the infrastructure I'm about to show you here. And I don't see it used in a lot of places, and it's really a shame because it could be effective at numerous different sites around the US and around the world. But anyhow, starting with that micronized limestone, moving to quicklime, they started with a pilot test in 2012, 30 million liters of Batman pit water. They treated it up to a pH of 6.4 with the micronized limestone. That 38 tons is about 2 tanker trucks full of micronized limestone. Then used 8 tons of quicklime to get it to about pH 7.5 using this reagent delivery system. So what this is it's called a dry powder shear. This is the pilot scale. I think engineers out there could probably create this in a day or two. Keep in mind, it is now patented by Micronized Minerals as of 2018. It's an Australian patent. And but I like this because it shows you the basic technology where you have this, the reagents are pneumatically conveyed to a floating edicator, excuse me, this is where the engineers are going to laugh at me, but basically a Venturi pump. And so basically this pressure drop occurs across this chamber where a vacuum is induced. It pulls the pond water, so you don't need high quality water, you don't need any water but the water that's in the pit or the pond, into this chamber where the reagents are blended together, and then it goes out through, hopefully you can see this diffuser here. And I'm going to show you the large scale design in multiple photos so you can see this diffuser. So then the pilot test, I'm not going to get into the results in detail because I really want to talk about the full scale results, but it was monitored for 3 months, shown to be stable in the pond. A 99% reduction of aluminum, copper, lead. You know, this is mostly hydroxide formation at these lower pH values, but they also did see some reduction in cobalt, cadmium, which may be more co-precipitation, absorption co-precipitation, and then also nickel and zinc, where you tend to think of them as the hydroxides being formed at higher pHs, but they were still able to get pretty good removal of those constituents as well. So moving on to the full-scale implementation, this occurred in late 2012 into 2013. What you're seeing here is this is the full-scale version of that dry powder shear, showing you the diffuser rig right here. And then a really cool, this is from Micronized Minerals, but a more recent photo, because I don't even think we were really using drones back in 2012, not really, but shows you how that diffuser really is able to mix the reagent into the surface really well. And I'm not saying that it's a perfect solution for every pit lake, but as you'll see in some of these slides, it's a very well mixed pit lake, whether it was acidic or alkaline. And so there was no need for additional mixing. I think that there's options if you need mixing that are low cost and like solar bees, for example. It took 5 months to complete, and I'd say for people that are thinking about using this type of technology, 5 months is probably a high end because they had some delivery issues with their reagents. But what is interesting is they were able to complete it, get very good results that I'll show in the next few slides. But in 2014, lots of water. There was concerns about the tailing storage facility, maybe the wastewater. I can't remember exactly where the concerns were, but nonetheless, the NT government, or I think it was the Department of Mines and Energy, asked Vista to pump additional ARD into the pit lake in 2014. So they had to retreat the pit lake in 2014. They had similar test results as far as, similar success with the implementation. And ultimately, they've got the infrastructure in place to do this at any time they want to or need to. There just hasn't been much need to. And so it's just something that by investing in the infrastructure early on, at any time, they can retreat the pit if they need to. I really like to show you a few photos of actual implementation. Here again, the actual dry powder shear, the diffusion rig. Showing you, I'm not exactly sure the phase this was in, but again, showing you in the background here. I'll show you a couple pictures, and I forgot to point this out to you. This is a low-grade ore stockpile, and we're actually looking to the southeast, so towards the process plant. So we are on the northwest edge of the pit looking to the southeast. Diffusion rig here. Okay, for those of you who like data, I'm showing you a community graphic basically that Vista has provided to anybody who's interested really. And what you have here is you have pH down to 3 as a function of time, and I'm just showing you 2012 through 2015 because honestly it was easiest to pull this off of their database without having to add more data. So nonetheless, I apologize, I've lost some of my indicators of like copper, nickel, lead, as far as these were supposed to be solubility kind of controls for the metals as far as their hydroxide. So you'll just have to trust me here. But what you see is you see the initial treatment. This is for quicklime moving up, limestone, moving up to quicklime, stabilizing at about pH 7, pretty close to that. This is where the addition of the ARD that I talked about in the last slide was, and then increasing the pH again due to the limestone, due to the quicklime, and then that pH dropping down and stabilizing. So when I showed this slide to one of my reviewers, they did mention that it would be important to state the following, which is I am showing you the center column or depth, the information from the center of the pit. But Vista Gold also was collecting data from the north, the south, from the pipe. So there's ample amounts of data. And what you see here is right now, at this point, we're dealing with like grab samples, basically. But in 2015, they installed data loggers. I think it was installed at more than just the center location, but ultimately, once they showed how stable the system was, how the variability in constituents there wasn't much variability throughout the water column, they've been more focused on the center of the pit. And you'll see that in these slides here. So I just wanted to show you some additional data, kind of an interesting way to look at it from 2017. And what you see here is the depth from 0 to about 90 meters. And that's obviously, you'll see all this data down here. That's all they've hit bottom. So nothing really exciting there. Maybe you'd call it a paste pH instead of a solution pH. But what you see here is you've got dry season and wet season on the bottom. And so the dry season, wet season, some variability, pretty much circumneutral pH throughout the whole column. And also these are like monthly, December, January, February. I think there were a few months that aren't necessarily included, but you get the idea, which is circumneutral pH, probably some evidence of, just meteoric water here at the top, maybe a little bit of acidity from wall rock, but keeping in mind that wall rock is not the same as rock, waste rock from these dumps or from the TSF that's been finely ground. This is a very hard rock. It is not a significant source of acidity to this pit compared to what you saw in these other or earlier at pH 3.2. Another thing to note is dissolved oxygen. This was a very oxic lake when it was 3.2. It remains a very oxic lake now that it's been treated. And then electrical conductivity. But the real data, I have no idea why it's slightly lower this month. I wasn't able to really figure it out, but the takeaway here is that it's still about 2,800 microsiemens per centimeter, still a pretty significant amount of electrical conductivity, but that is associated with probably majority of that is sulfate. And you rephrase that, sulfate is not well treated by alkaline reagents, but the amount of sulfate that they need to treat down to is such that it really wasn't their priority to focus on the sulfate removal. So anyhow, that's just another indicator of how there's not a huge amount of variability. For those of you who like limonology, I suppose you could argue, we could discuss, not argue, discuss a potential chemocline, thermocline here, and I have some temperature graphics if you really want to get into it. But nonetheless, a well-mixed near neutral pH lake with oxic conditions. And then one more graphic, just because I love a good depth profile, showing you the down to 70 meters in 2020. Again, this is as deep as the lake is, probably more of a paste pH, but you can see near neutral, kind of slightly less than neutral pHs at about pH 10. Could say, this is probably a little acidity input, probably a little bit from rainwater as well, but this kind of tick up a little bit here does say maybe a little bit of acidity there. Let's focus though on depth again as a function of concentration here. And what I'm showing is copper in blue, aluminum in gray, and zinc in brown. And what you can see here is, remember when I said it was about 112 milligrams per liter of these constituents? I mean, now we're looking at 1.5 milligrams per liter in total. So maybe this is a log scale, so much lower than what was initially there. Okay, moving on. So for the engineers, I imagine that this is probably more interesting to you than it is to me. But dewatering pump system is actually 4 500 kilowatt variable speed centrifugal pumps. And so what you have is there's these, each of them is on a floating pontoon. Each of them operates separately, independent pump design, a combined maximum flow of about 1,000 liters per second, I think maybe a little bit more. And the flow rates are automated through telemetry. This is actually the discharge point here. It is not on Edith River, which is the protected stream about 1 kilometer away. It's actually at Batman Creek, and then it makes its way down to Edith River. The flow rates are continuously logged. The pump status, sorry, that's a little bit of a typo here, but the continuous logging of pump status, flow rates, and Edith River water levels allows the operators to set their flow rates based on the discharge license conditions. And so this is important. I'll talk about those discharge license conditions in a second, but let's just go to some real-time data. So again, this was an interesting graphic that was provided in the wealth of information Vista makes readily available to anyone. In 2015 to 16, this is basically from December to March is when most of the water occurred in this year. A lot of it occurs, rainfall occurs in, let's say, January, February, March. And so this is flow rate right here, multiply it by 1,000 to get liters per second. This is cumulative volume, divide it by 1,000 to get gigaliters. And what you see here is that in about a month, they were able to pump for, I think it's 35 days. These are non-consecutive days. And they were able to remove approximately 1.5 gigaliters of water from Batman Pit. And so they did this with a 23 to 25 fold dilution. So 1 part Batman Pit water to 23 to 25 parts Edith River water. And I think it's important to note, this graphic shows you, this is rainfall during that time frame, or maybe a little bit longer. But as you can see, you've got the total rainfall here. And then this is the water that's released in gigaliters. So as they're releasing water, the pit is filling up with water. So even though they've discharged 1.5 gigaliters of water that year, which would have been like, 13% of the total volume initially, they're still constantly dealing with more water entering to the pit. And so in this time frame in 2021, they discharged approximately 2.24 gigaliters of water, and that was about 20% of the initial volume. So one of the reasons that they've been able to discharge at this rate of about a 20-fold dilution instead of a 5,000-fold dilution is the numerous ecotoxicity studies that they've done on Batman Pit water. So they've done looking at the water fleas, and in Australia, I think they do 7 or 8 different species to look at whether the water is toxic to them. They do it initially much more regularly than now, but I think it's, I'm not exactly sure how often they do it, but at least annually. And then they do this direct toxicity assessment. So basically they were able to determine at an 80th percentile species protection level, they could discharge Batman Creek water and not negatively impact Edith River. And so that, in addition to having the water quality be treated by the alkaline reagents, they were also able to negotiate down to 80th percentile, and that allowed more discharge to occur. And so I'm looking here just to show you some of these trigger values here. So the parameters, these are what they're regulated for in their waste discharge license, and the units for that, just to differentiate milligrams from the trigger values. This is at the downstream Edith River compliance point, let's say. So pH 6 to 8, oxic waters, an electrical conductivity of 250 microsiemens per centimeter. So these are very different than, let's say, what we would have in some other communities. Like, for example, let's say sulfate. I'm really often thinking about 250 milligrams per liter, but they're required to meet 129 milligrams per liter here. But obviously, like things to look at, copper at 2.5 micrograms per liter, that's obviously going to play a large role in the dilution factor that they are setting their system at. So I actually have a note here that they do annual macroinvertebrate monitoring, annual sediment monitoring, regular ecotoxicity assessment. And I know that during their discharge, they're doing daily monitoring of field parameters, weekly monitoring of metals at the actual discharge point, but then they also are doing things in the pit lake that aren't required. At least I don't think they're required. I couldn't find it in their discharge license, but they're just doing it because it makes sense and it gives them more information about the system. So because I love a good picture, I'm showing you the pit. Again, remember where we are. We're on the northwest-ish corner of the pit, looking out at those stockpiles at the process plant area over here. And what we have here is less than a gigaliter of water remaining, I think 0.85 gigaliters. So this is during the wet season, so they were still discharging at this point. But keep in mind, I want to show you one more picture just from a slightly different perspective in March 2021, and then show you what they started with from pretty much the same perspective. So here is 2006 prior to their involvement, standing in about the same location, and then looking at with less than a gigaliter of water remaining in this pit. So they are very close to being able to make a decision about how to proceed at this mine site with now that they've almost completely dewatered the Batman pit. So in summary, hopefully you got the takeaway that they've used an extremely methodical approach to select and develop a cost-effective and low-risk treatment strategy that has clearly worked. I think one of the things that I like about working for Vista Gold is this weight of evidence approach that they use. You know, they use it not just here, but in everything they do, is that they have been able to demonstrate that treated discharge is not going to impact the downstream community, the aquatic community. And so they're a real partner for the NT community, for the Jawoyn people, and you know, they make sure that the information that they collect is out there, and anyone, the information I just showed you in this slide, besides the slideshow, besides the photos, are readily available to you as well. They automated the dewatering system so that they could get real-time data to adjust their flows on the Edith River and adjust those trigger values as needed. And I think, again, this continuous transparency that they've shown throughout this process, it really makes them a leader in that, you know, demonstrating what other miners or juniors or companies in their position should be doing as far as if they want to advance a project and have the community, you know, backing them, and their consultants proud to be a part of the team working for them. So that is it. I appreciate your time. Thank you.
Awesome. Thanks a lot, Dr. Moran. This is really, really interesting, and glad to see the change the last 15 years, where it has started and where it has ended. It's a lot of work and a lot of brains just gone into it to achieve that. I'll move into the Q&A session. Please post your questions in the chat box, and I think with the number of participants, I'll let you ask the questions by yourself. The first one is from Jenny. Do you want to go ahead and ask it?
Sure, I can do that. Can you hear me?
Please.
Your great talk. Thank you so much. I appreciate it. Can you tell me the goal is the goal to drain the pit completely, or to close it, or are they going to restart the mine, or what is the goal in the end?
Sure, I probably should have made that more clear from the beginning, which is that the goal is to restart this mine. If you have interest in kind of the bigger picture, like I mentioned, the 43-101 document goes through the actual kind of enlarging of Batman Pit. And I think some of the recent announcements that show that the mineralization is open on both ends, you know, so the world is their oyster right now. So the goal is to restart the mine, but ultimately the goal is, for me, I think for the community too, is to capitalize off of that mining operation, but to also properly close the mine. And so they have a, you know, kind of modern best industry practices for closure plan. And I'm of the opinion that I'd like to see more abandoned mines go through this process.
Thank you. Jeff has a question. Jeff, do you want to go ahead?
Yeah. Hey, Patsy, great presentation. This is
Hi,
Jeff. Hey, just had a question about when they get to the bottom of the pit. Any ideas on any management plans for there's probably alkaline sludge down there. Wondering if that's going to be characterized for metals leaching and any strategy for dealing with that material?
You know, I can't speak for Vista because I'm not 100% certain what the strategy is. So let's just say this is Patsy speaking for herself, what I would say to do. So they have done some characterization of that sludge. And it's clear that the majority of the metals dropped out early in the process, and that the metal kind of milligrams per kilogram in the upper portion of the alkaline sludge is pretty low in comparison. So I think because it's a relatively small volume of material and they're planning to mine the pit, it'll be a much larger pit. My personal opinion is that they should mine that sludge, put it into one of the facilities, make sure it's not accessible, you know, kind of treat it like you would potentially acid generating rock in your waste rock dump. But I do know that April Hussey, if she is on the phone, she might actually know exactly what the plan is for that material. So
Yeah, thanks. That makes sense. Thanks.
Thank you.
Patsy, this is April. I don't know that we have looked at the specifics regarding that sludge. There are certainly a number of options to handle that, depending on the exact characteristics and the timing of when that would come out, and not the least of which would just be to place it in the existing tailings facility.
Yeah, that's a good idea too. Yeah.
Thanks, April, for pitching in. And if you have more questions, please.
So has there been any activity? Like, can you tell how much the mine's worth currently if it were to start producing gold?
I am definitely not the person that can answer that question. However, it is, and I feel like I'm beating a dead horse here, but that information is readily available in the 43-101. And you know, I don't know if you ever attend those talks where they say those are forward-looking statements, and then they proceed to tell lies. And I'm just joking, not Vista, but that's what most of the junior miners say, forward-looking statements. So I would not even venture out on that ledge because I am an environmental geochemist. But I mean, what is gold today? You know, somebody might know, what is it, 1800? It is a good time to start a mining operation right now.
You can pay for the whole thing.
We are very, very busy in the mining consulting world right now.
Thank you. Garrett, do you want to go ahead and ask it?
Absolutely. Hi, Patsy.
Hi.
So when you got the environmental consent to discharge, are there any ongoing water monitoring requirements at the discharge point? And have you noticed any variation in the pH?
Sure. So the waste discharge license, which is publicly available, has extensive water quality monitoring requirements. So I've really been focused on the downstream compliance point, which is not the language you use in the Northern Territory, but it's the language I'll use here. And so that monitoring is, I mentioned that daily at that monitoring point for kind of your field parameters to see if there's any obvious variability that's occurring, and which would probably stop the discharge. But then also weekly at the discharge point, and then monthly throughout the year. Not exactly sure of the requirements. I just know that there's at least 5 locations upstream, downstream within the mine site that are required. And then I know Vista Gold has data loggers installed in the pit lake. So if they were to see any variability, that's a decision that they would make about whether they might increase their dilution ratio so that they could make sure that they would not exceed those trigger values. But yes, there is some variability. I tried to show that a little bit, that, you know, especially during the wet season, where you see a little bit of change in pH at the surface. And so, but as far as stability, it's much more stable than you'd think for kind of a pit that was really not very hard rock, lots of inflow of groundwater moving through that rock. And I did forget to say that, which is this rock is highly silicified, highly hard rock. And so I apologize to the hydrogeologist, I'm about to say this, it's a bathtub, you know? And so what that means is the majority of the water coming in is coming from the surface, from meteoric water, and from runoff from the wall rock. And so of course that has a certain amount of load associated with it, but not to kind of what I've seen in other places where every, you know, spring you have an ARD signature and then you're treating, and then every spring you're treating constantly. It's just not the scenario they have here. So I think they're pretty lucky that they have something different than, I see Jim Gusick's on the line. He likes to deal with those.
Thanks, Patsy. Thanks, Garrett, for the question. Does anyone have more questions? So I have one, mainly from a geochemist point of view, like how do you decide to, like, what is the scope? Is it just for water treatment, or also in the future how the treatment methods are going to impact the pit's future? Like what would happen to the rocks with what chemicals you're going to be using, and what processing which would come sequentially, or any other long-term impacts and things like that? What scale do you evaluate those things?
You know, I think I understand the question. And so I go back to the way they selected the in situ technology, kind of an alternatives evaluation, where you're not just looking at treatment success, but you're also looking at the cost associated with it, the community perception, the time frame to implement it, the potential risk associated with discharging it. And so I think that approach is, you know, I definitely think that approach is appropriate for future consideration. My understanding, like, for example, I mentioned that they have a closure plan that, you know, for when they actually close the mine, I don't even know what the mine life is, but let's say 20 years down the road, that they have a kind of world-class closure plan that involves making sure that low-quality water isn't discharged from this mine. And that April, for example, would have been involved in that decision-making associated with what water treatment technology they picked for the closure portion of this operation. Did I answer that question? I feel like it was a little...
Yeah, I kind of broke it up in a very different sense, but yeah, you answered my question. Thank you. Are there any more questions from the audience? Feel free to unmute yourself as well.
1736. Thank you, Tim Arnold. Don't see any more questions in there.
So Alex has a point, 13 year mine life as per NI 43-101.
Okay, yeah. Admittedly, I thank you for pulling that up. I should know that off the top of my head. So
yeah,
that.
I immediately pulled up the 43-101 when questions started coming up. And it's
Thank
about
you.
an 800, what is that figure? $823 million after-tax NPV.
Nice. Thank you. That's for you, Pete.
All right.
All right. So there's another thing I wanted to, I just curious in the presentation is like the variation was more consistent in depth compared to the surface, the initial 20 meters, and you had your plot showing top 20 meters and the whole pit as well as comparisons. Like I'm not that familiar with it, and so is there a reason why the variation is high more towards the first 20 meters, and then towards the depth it becomes more consistent?
Yeah, so admittedly, I see that as not very, we're going to get into chemocline, thermocline, limnology, which is probably not. Let's see if I can go. Is this the one you're talking about?
Yeah, yeah.
Okay, so, and you can see this, geez Louise. Let's see if I can go back there again. Try that one more time. So I'm not going to try to put it into presentation mode, but there is a kind of a liminalogical influence here. It is not without any chemocline or thermocline. And so I'm actually going to pull up the temperature. So what you can see here is this just shows you that there is a thermocline present here. And so during the wet season, 31 degrees at the top, wet and hot. And then at 20 meters, you get to the point where the temperature is very consistent. And so it's just a kind of pit lake influence that we need to take into account when during treatment. It's also, I suppose, in part helps to move some of that reagent through the pit lake as well.
Makes sense.
I don't consider myself to be a liminologist, and I think that response did a really good job of proving that.
Thank you. Are there any new questions from still got a few more minutes? We can conclude the talk today. I guess because this has been a really good talk that people have most of their questions answered before it says.
I'd be worried if there were no questions, so we've got just the right amount of questions.
So is that something you see as a geochemist in your experience that in reclamation projects like these, is it a similar trend that it takes about 10-15 years for the whole activity to go ahead? Or
no, I mean, part of this was the market. Part of it was, this is a little unusual. They could have treated this more quickly, not treated it, but discharged it more quickly if the timing was right. But I think that it was a decision that Vista Gold made as far as knowing that they were willing to make the investment and the time frame. So I guess, it goes back to that alternatives evaluation, is that they had the time to discharge 1 to 2 gigaliters of water per year to dewater this pit. And they're at the point where they're very close to actually being totally dewatered. So I would say it's a bit unusual, but it worked out okay for them. And the timing, I think, for them being able to show this now with the price of gold, I suspect, and this is just speaking for me, that there was a lot of interest from other companies in this mine site right now.
makes sense. Awesome. I think it's about time, unless we have any more questions. Thanks a lot, Dr. Moran, for joining us today. And it was a really interesting talk to learn about how closed mines can be restarted and what the process goes about, and the technicalities of it, especially for mining engineers. It's a lot of new information we learned today. Next week we have a talk. It's not in our usual 4 o'clock time. It's at at morning 10 o'clock because we have our friends joining from Europe. The talk is going to be about impact of blockchain in mining applications and where we can optimize things. It's a really interesting talk, and hope you all can join us next week along at 10 o'clock. And thanks to everyone for joining us today. It was really interesting, and hope you learned something, and hope to see you all next week. Thank you, everyone. Have a good day.
Thank you. Appreciate it, everyone.